you'll see today most of the material very similar to everything we've already done. The fundamental theorem of algebra says if you have a polynomial with an nth degree, a fifth degree, a seventh degree, a third degree, the biggest power, that's what we're talking about when we say a degree, then you should have precisely n zeros, meaning whatever the power is, you should be able to find that number of zeros, that number of factors, that number of solutions for the polynomial. So power is 10, might take a little bit of work, but we should be able to find 10 zeros, 10 x-intercepts, 10 factors. They can be real, and now they can be imaginary, so we're going to find all of them, not just the real ones. In order to do that, there is a process that we can use that we've been using, and there are 4 steps here for you to think about. The first 2 kind of go together. So we graph it in the calculator to find the real zeros. We use the rational zero test, which is finding the p over q values, as the algebraic support as to why we can look things up in the calculator. So the number we choose from the calculator should be in that list because it's a rational zero. And then we use synthetic division to divide that zero out, and then we take that piece of information after we divide, and we hope that we can then factor it to get the other zeros, which is pretty much everything that you did on the test question number 2, which was really good. Like, everybody did really well with that question, where you had to pretty much look up information in the calculator, use synthetic division, break it down, factor it, compute it, find all the zeros. So that's what we're going to talk about today. The answers are going to be real and imaginary. Before we get to that part, if you look at the 3 examples that are underneath, that wants you to find the zeros. If it's factorable, or if you can set it equal to 0 and solve, then you don't need to do all of that information. You don't need to do the rational zeros because you're not looking up in the calculator to find those values. So instead, like A, B, and C here, if you can solve it easily by factoring, by setting it equal to 0, come on, buddy, here we go, then do that. So the first one we have f of x equals x squared minus 2. Well, if I'm solving this and finding the zeros, set it equal to 0. Take the 2 to the other side. Take the square root because it says x squared. And then your solution would be positive or negative square root of 2. Power is 2, we should have 2 answers. That's it. So if we can factor it or solve for it by taking the square root, then always do that first. The second one we actually did yesterday, but just a quick little review. So make 0, take the 1 to the other side, so now it's a negative. And then when you take the square root, the negative is the part that makes it the imaginary, and then we still have the square root of 1. So Brandon, the square root of 1 is?
1.
Or?
Plus or minus 1.
Right, plus or minus 1. The I is there because you took the square root of a negative number. Just don't forget the plus or minus. Anytime you take the square root of a number, you're taking the square root, you're solving for x squared. There needs to be 2 on the left and the right of the graph. Now the last one's a little different because it says x to the 4th minus 4. You cannot just take the 4 to the other side and take the 4th root of it. It's x to the 4th. It's not x squared. Brandon, what do you think?
We can split up into x squared plus 4 and then x squared minus 4.
How about instead of 4?
I mean x squared plus 2x squared minus 2.
There we go. And you can do that because
4 is a perfect square.
there you go. 4 is a perfect square. So this is a perfect square. The 4 is a perfect square. So you can factor it as x squared plus 2, x squared minus 2. Then you solve them like the other 2. You can just write plus or minus I. I was writing the 1 just to emphasize that we did really take the square root to get the plus or minus part. Other questions? So if you solve these 2 little parentheses, we would have x squared equals negative 2, x squared equals positive 2. So once it's factored, solve the little parentheses, take the square root of both sides. So we took the square root, it's a plus or minus. There's a negative underneath, so that makes the I. And then we have the square root of 2. So 2 answers are plus or minus the square root of 2. The other 2 answers, taking the square root, we just get plus or minus square root of 2. So the one has the I with it because the negative was underneath the square root. The other one doesn't because it was a real number. 4 answers still, 2 imaginary, 2 real, to go with the power of 4. So you don't take a 4th root. You won't get all 4 answers if you take a 4th root. Instead, factor it and break it down. So pretty much, you need to be able to break it down to x squared so that you can solve it, that you can factor. Questions? So we're going to do one pretty involved problem, but I think it's pretty straightforward, just a little bit of work here, using those 4 steps from above. So we have this polynomial, x to the 5th. How many zeros should we have? 5. It tells you 5 zeros we're going to find. We're going to write it as a product of linear factors, and then it says to list all the zeros. So that just means in the end, I should have 5 parentheses and 5 zeros. So both ways to kind of write our answer. Using the steps that are listed above, going too far, we're going to graph it, and we're going to use the rational zero test. Those 2 pieces go together. When you graph it in the calculator, we're going to find the real zeros. The imaginary ones you will not see. Algebraically, we'll find those imaginary zeros. So if we start off with the rational zero test part, come on. So here's P. Q is in front. Q is really a 1. Libby, the factors of P are?
1, 2, 4,
Yeah. And if you divide them by 1, do they change? No. So now, using that piece of equipment that I don't like a lot today, but if you could take out your calculator, we are going to find the real zeros. And they should be in this list. So that the rational zero test is supporting the real zeros that we're finding. A 0 is x equals. X equals 5, x equals 10, x equals negative 20. But a 0 is x equals, because that's the x value you're looking up in the calculator. All right, so they have a 0. Chelsea? -2. And -2 is in my list. So, 4th one up there. How about another 0? Chelsea? 1. Are there any others? There is. 1's a double root. How do you know it's a double root, Chelsea?
Because it doesn't pass through.
It doesn't pass through that point. So I believe your graph, I don't know exactly what it looks like, but if this is the x value of 1, it's a minimum at that point. So because it's a minimum, the fact that it's a double root is actually really important. We need to use that to help us with the synthetic division. So we now have 3 zeros up here. 2 of them are 1. The third one is -2. We need to find our other 2. So we're going to use synthetic division, because that will be the next step. So we have the zeros, the real ones. We did P over Q. Now we're going to use synthetic division. So we can start with the -2. That was the first one Chelsea gave us. And then just be careful that you look at the problem and you make sure that all the pieces are there. There isn't an x to the 4th. So we have a 1x to the 5th, 0x to the 4th, 1x cubed, 2x squared, -12x, and then 8. Make sure you're taking the time to see that they're all there. If you miss that part, then the synthetic division thinks it's an x to the 4th graph instead of an x to the 5th graph. So this is the part that should be pretty quick for you, the synthetic division. So synthetically divide, bring down the 1. I think I took up too much space. Make sure you get a remainder of 0. If you didn't, that's a little hint. A, you did the synthetic division incorrectly. So we started with x to the 5th, divided once. This will be an x to the 4th polynomial. What do you do next? Alex? And what are you going to divide with?
Well,
What numbers do we put up top here?
the answer that you got.
Yeah, the answer that you got. So our goal is to break it down. So now we're going to use the answer we just found that was already broken down to x to the 4th. Take those coefficients and we're going to do synthetic division another time with the second 0. There were 3. So now we've already used the -2. Now we have to go to the next one, which would be a 1. And again, use synthetic division. Alright, so this is now x cubed.
We can use a 1 again.
And we can use a 1 again because you had 3. So we're going to use the 1 a second time because it was a double root. And the new answers. So you're always using the new answers that you get. Those new coefficients that you use to break it down. And that is a 1, a -1, a 4, and a -4. Okay, so we've done synthetic division 3 times. Because we used synthetic division and we got a remainder of 0, we divided with a -2. As a factor, that means x plus 2 is a factor. We divided with a +1, that means it's a factor. We divided a second time with a +1, it means it's also a factor. And then what is left would be that remaining piece, which is 1x squared plus 4. So the question said, rate it as a product of linear factors. This is not linear yet because it says x squared. We can find the zeros and then transfer those zeros to be in factored form. So if you take this piece and set it equal to 0, Libby, what would our 2 other zeros be?
It would be I, or plus or minus I, 2.
So just put the 2 in front, plus or minus 2i. So taking that last piece, we can now solve for it by setting it equal to 0. It doesn't get factored. Just solve, taking the number to the other side, taking the square root. So then we have x plus 2. We have x minus 1 twice, so you can square that instead of writing it twice. And then x plus 2i and x minus 2i. So this is a product of linear factors. Each one of those factors, the numbers in the middle of the parentheses, is linear because it says x, it doesn't say x squared. Now, yes, that quantity squared, but the part in the middle is the x minus 1, the linear part. The 5 zeros, we found 3 of them with the calculator. The other 2 are the plus or minus 2i. So here's our zeros. Now they're real and imaginary. And then our factored form way down here. So not necessarily hard. Involved, yes, because we use synthetic division 3 times. Questions? So if it said x to the 4th, you'd use synthetic division 2 times. The goal is to divide till you get down to x squared. So whatever the power is that you start with, you need to break that power down with synthetic division till you get to an x squared equation, because then you can solve it by using factoring, using the lovely formula, or just setting it equal to 0 and solving. Questions? So the little statement underneath talks about complex zeros and the conjugate part that we said yesterday. So complex zeros occur in conjugate pairs. That means if you have 5 plus 2i, you're going to have 5 minus 2i. If you have a positive 2i, you're going to have a negative 2i. They always will go together. So if you have an I, you always have to have a negative I, no matter what. Because when you're finding a 0, the way we get an imaginary 0 is by taking a square root. Well, anytime you take a square root, you have a plus or a minus answer. So no matter what, you'll always have 2 imaginary solutions to every single problem that we do now. So you'll have a couple real, always 2 imaginary, not just 1 or 3. It's either 2 or 4 or 6.
Even amount.
Even amount. Exactly. That's right. Question. Okay, we're going to skip the problem at the bottom. We might do that as a warm-up tomorrow. And I want to do this problem that talks about conjugate pairs. Kind of deals with that. So it says find all the given, or all zeros. So we want to find all the zeros based off of the fact that 5 plus 2i is a 0. From the equation x cubed minus 7x squared minus x plus 87. How many zeros should there be? Virginia? 3. How many do you really know, Virginia?
2.
Why?
Because it has to be 5 minus 2i.
Yeah. So even though they say there's 1, there's actually 2. Because if you have 1, you've got to have the other. It's conjugate. So the other one would be 5 minus 2i. So we're just missing 1 0 instead of having all 3. Now, yes, you could look this up in the calculator and get that other 0. But that wouldn't be really using the information they're giving you, because I would just be looking up in the calculator and finding that other 0, which is fine if you're checking your work. But since they're telling you that one of the zeros is 5 plus 2i, probably should use those zeros to help us find the other one. How do you think you would start that? Virginia?
You said 5 plus 2i equal to x.
And then what?
You would solve for 0.
Yeah. So she said we set them equal to x, and then we're going to see if we can then solve it so that it's equal to 0, which means we're going to make them as factors. Part of the question says write it as a product of linear factors, so we might as well write them as factors if we have 2 of them. If you're writing it as a factor, you need to move those to the left so that they're next to x. So if you have x equals 5 plus 2i, what does that look like as a factor? So if you take it to the other side, what would it be as a factor? Virginia? What do you have to do the x or the 5 to get it to the other side?
You subtract it.
You subtract it. What do you have to do the 2i to get it to the other side?
Divide by 2.
How do you move it?
You
You just subtract it. Yeah, so we'll just subtract the 5, subtract the 2i. So with the other one, we still have to subtract the 5, but it's minus 2i, so to get it to the other side, we have to add 2i. Okay, so this looks really huge and confusing. But if you remember, if you multiply complex conjugates together, what's supposed to happen when you multiply complex conjugates? Chelsea? The middle terms cancel out. So when you multiply these, we're going to do some cheating here, a little bit of cheating multiplying. These 2 pieces are the real numbers. Those are actually your first term, both of them, because they're both the real number part. We're going to multiply those 2 pieces together because you're supposed to multiply the first, the outer and the inner cancel, and then the last. So if you multiply x times 5 and x times 5, what do you get when you multiply them together? Brandon?
X squared plus 25.
X times x times negative 5,
minus 10.
minus 10. There you go. So we're multiplying the first 2 pieces together. X minus 5 times x minus 5. We're skipping the outer and the inner because they cancel. And then you multiply the two last pieces together, and Brandon, negative 2i times positive 2i makes. What do you know about negative 4i squared?
It's just 4.
This is just plus 4.
So then it'd be x squared minus 10x plus 29.
Very nice. Okay, so we no longer have imaginary numbers. We have this expression that is a real number, but it's a quadratic expression that we are going to use to break this down. And now at this point, breaking down, we have two methods to break something down. Factoring is out because you can't factor that out. Synthetic division and long division are the ways that we break stuff down at this point. Synthetic division doesn't work because it's not just x plus 2. So we're going to use long division and our original equation to see if we can use this to break it down. So we're trying to pull this out of x squared, nope, x cubed, minus 7x squared minus x plus 87. Because the leftover piece, if you're pulling out the imaginary parts, should be your real answer. So you have an x squared, we need to make it an x cubed. That means we have to multiply x squared by x. So we have x cubed, 10x squared plus 29x. Subtract, be careful with those signs. This turns into addition, the second one turns into subtraction, leaving us with 3x squared minus 30x. And then you bring down everybody in Pittsburgh's favorite number, 87. Divide again. You have an x squared, we need to make it 3x squared. What do you multiply it by? 3. So 3 times x squared, 3 times negative 10x, 3 times 29. If it's a factor, you should get a remainder of 0. Whether you do long division or synthetic division, it's going to be a remainder of 0. The piece that's left on top is that extra remaining 0, right here. So this is our 0. This is our factor. That's the real part. We use the imaginary pieces to pull out that real part. Questions? Again, like 2 big problems. We've done 2 problems really, 2 big ones. Alex.
So it says write as a product of your factors. Would we write it like
So I'm going to go back. I'm going to cheat since we already have this here. So we have 2 of our factors already written. The third factor is x plus 3. And now it's written as a product of linear factors. So the imaginary ones we already had. Here's the real one. And then the third solution would be a negative 3. That's the one we found using the long division. Questions? So we'll wrap this section up tomorrow, but you can see like the problems are big. Not all of those problems are big. I think the first half is just quick factoring problems. That like, there'll be like 2, 3 big problems that you'll have to work on. Like that 62 is a big problem. I think 69 actually is a calculator problem. I think it says use the calculator. How about that?
We have to.
No, you can do this synthetic division. Unless you're finding a max or min, you don't have to use the calculator.
I feel like one bonus point test would be motivation and not using calculator.
You think so?
Yeah.